Hey, good morning, everybody. You doing okay this morning? I'm Chuck Lofton, and welcome to our live session of the Weather Academy from a room in my house. How about that? We're not in a school, and we're not at a Knights of Columbus or at an Elks Club today. Okay. Oh, I'm sorry. We're back. Okay. Good morning. I'm Chuck Lofton. Welcome to our Weather Academy here at Channel 13. And I'm inside my house today. I'm in a little room, excuse me, and I've also got a frog in my throat. And we're going to be sharing a lot of fun with you today. This is the third of our at-home Weather Academies. Perhaps you saw the first. That was with Lindsay Monroe. And then the second last week, that was a Weather Academy that was a lot of fun with Angela Buckman and her daughter Grace. And today it's just me, even though we may have a guest. He kind of does what he wants to do, so he may just kind of jump in and say hi sometime during this. But we're going to do a few things today. We're going to recap some of the things that you may have already learned. So if you've already seen two of them, then we're going to recap just because it's so important, some of the key points from there. We're also going to talk about severe weather today. And then secondly, we're going to have a great time, I guess thirdly, we're going to have a great time reading a book. And the book is called Let's Talk Weather. And this is a book that's written by a television meteorologist, a friend of mine named Amy Sweezy down in Orlando, Florida. And even though she's going to be switching careers, she's done a great job as a meteorologist. And she's going to share some of her knowledge with us. Okay. If you have any questions at all, I want you to send them to me on Facebook. Say hello already. We're saying hello to Alexander and to Carla and to Sandra, and thank you for watching. Okay, is this on? Guys in the control room, tell me if this is on, because I'm getting a message that says our stream is over. So we're back. We're back. Okay, good. All right, let's begin with our Weather Academy. You ready? Today we're going to talk about spring storms, and that's Angela Buckman right there, and she's going to help us as we learn about spring storms. Spring storms can bring severe weather, and that's that time of year. We're in April, and so that's the time of year when sometimes we often do have severe weather. So let's continue here. I think the thing that everybody wants to talk about, and the most common question that I get, it doesn't matter what age group, is about tornadoes and the effects that they have. Well, a tornado is a rotating funnel-shaped cloud that touches the ground. Now, sometimes you see things that may be swirling out of a cloud, and those are funnel clouds, but they're not necessarily tornadoes. A tornado touches the ground, and we're going to show you a great example of that coming up in just a little bit. Tornadoes have been reported in every state and can happen at any time of the year. You're going, whoa. You mean in December at Christmas time we can have tornadoes? You bet. In fact, we've had tornadoes every month of the year in the state of Indiana. And it is true, a tornado may sound like an airplane or a train. Okay, let's talk more about severe weather in regards to tornadoes here. Do you know what a myth is? A myth is something that's generally accepted as being true, but it may or may not be true. And these are all myths, things that really are not true. Here's one of them. Tornadoes don't occur in the winter. You know, as we mentioned, that's absolutely not true. Tornadoes can happen at any time of the year if the conditions are right. And we're going to talk about those conditions in a few minutes. Let's go on with some more tornado myths. Tornadoes will never hit the same place twice. Well, that's not true. There is a town, and many Hoosiers are familiar with it. It's called Xenia, Ohio, and nearby Xenia is a Cedarville University where many Hoosier kids go to college, and there's Wilberforce University as well, Central State. Nearby there is Xenia, Ohio. That's the home of Athletes in Action. That's a ministry. And back in 1974, it was hit by a massive tornado. Much of the town was destroyed. And you know, the same thing happened in 2018. Massive damage, and it was the same place. How about another tornado myth? And this is one that, believe it or not, when I was a boy, I used to believe tornadoes never hit big cities. They're too big. A tornado won't go in there. Well, that's not true. Miami, Salt Lake City, Fort Worth, and other cities have all seen tornadoes. In fact, when several years ago when a tornado hit Fort Worth, I was there in Texas just a couple of weeks later for a convention, and my goodness, big tall buildings had windows knocked out. So those are some tornado myths, and we're dispelling those for you right now. You know, the most important thing that Mr. Sean or Lindsay or Angela or Kelly or I could talk to you as a weather team is about watches and warnings, because if you get those right, if you know those, you're going to be safe. So let's talk about watches and warnings. And by the way, we want to thank Amanda and Linda and Francis William for watching us this morning too. And Sean and his family are there. Okay, so let's talk about this. Do you know the difference between a tornado watch and a tornado warning? Well, Jade, you're watching, so let's ask you, do you know? Well, tornadoes are always threats when there's strong weather. And there is a big difference between a watch and a warning. Can we come back to me, Dale, first on camera? And I want to show you graphically how I look at watches and warnings, and then we'll look at those definitions. If you're watching for something, if you're saying, hey, the ice cream man is coming to town, let's watch for him, you're going to do that. You're going to watch, right? He's not there yet, but he's coming, right? But if in a warning, that means something is already there. So there's a difference between a watch and a warning. A warning is much more severe. So let's take a look at those definitions. So in a tornado watch, tornadoes are possible in your area. You may see us come on the air and say there's a tornado watch for the state of Indiana. Stay tuned to Channel 13 and make sure that your parents have the live Doppler 13 app on their phone. Now, if there's a warning, that's a completely different thing. A tornado is either on the ground or has been detected by Doppler radar. Seek shelter immediately. And there are two ways usually that we get a warning. Either somebody sees one, or we think that we see the outline or the echo or the signature of one on radar. All right, let's continue here on the Weather Academy this morning. What do you do if there's a tornado warning? Well, if you hear a tornado warning, what you want to do is get to the lowest possible area of your home. If you have a basement, that's an awesome place to go. But you say, hey, I don't have a basement. I live in the third floor of an apartment. What do I do? You try to go to the lowest possible level that you can and seek shelter. You know, when my boys were little, I used to say, hey, the best place in our house to go is downstairs in the bathroom, because there were no windows in our bathroom. That's what you want to stay away from, windows, because those can cause damage to you. So stay away from windows in the lowest possible level. Have you ever seen a tornado? Well, you're about to see one right now. We spotted a tornado. This was in 2016 in August, and our weather team was in the studio telling people how to stay safe. And I was actually, along with our photographer, Joe, tracking this tornado. This was in Grant County. You know where Grant County is. That's where Indiana Wesleyan and Taylor University are, near the town of Swayze. And those are the highway signs, 35, 22, 19. And notice that tornado. Remember the difference between a tornado and a funnel cloud? What was it? Right. The tornado is on the ground. It's causing damage and debris. But if we stick with this video just a little while longer, look how the tornado stops and it becomes a funnel cloud. But we knew that that thing was going to drop again, so we continued to follow it. Let's go on to our next piece of video here. And during that day, while Sean and Angela were on TV, I was following the tornado. Now, something weird happened. The National Weather Service said there is now no longer a tornado warning for Grant County. But I was in Grant County, and I was following the tornado. So I said, you know, let's pretend that tornado warning is still in effect, because I think it's going to happen. So watch what happened right here.
Thank you. And you know, many of you thankfully sent in videos like this one of the funnel clouds actually touching down. Even when the tornado warnings expired, our own Chuck Lofton stayed on the storms this evening. In fact, he was sensing things simply weren't done, and he was right. Just a few minutes later, another tornado dropped, and he was there as an eyewitness. Here now is a little bit of Chuck's coverage this evening near Swayze in Grant County. Take a look.
Joe, does that look like a funnel cloud?
Yeah,
We're seeing a funnel cloud drop right now. It looks like we're seeing a funnel cloud and possibly a tornado.
We have a tornado now. It looks like it's on the ground.
Oh,
We're going to
wow.
slow down here and try and stay safe.
Some damage, not as much as it could have because it was in a rural area where there was a lot of corn and a lot of beans coming up at that time. But there were some folks with a company called Nighthawk Productions, and they were near us, but they were far away from the tornado, and they sent up a drone. And I want you to look very closely. By the way, if you're having trouble on your feed, on your laptop computer, go to the Facebook app. We're not having any problems there. Okay, let's watch this. And notice the center of your screen. That is a defined funnel cloud that is a tornado. In fact, I believe actually that Joe and I are to the right-hand side of where you are watching this. We're in that van, I believe, with the headlights on. So we were near it as well. But this gives you a really good view of the strength of that tornado. And notice, as we get this drone footage closer, we're going over these soybean and corn fields here, that you'll see just a little bit of debris flying out of that. Debris is, pieces of shingle and pieces of wood and parts of a barn and parts of a playground. All of those came out of that area. Now, you may be asking, hey, why is that drone so far away? Well, as we're going to mention a little bit, tornadoes are very strong, can have winds in excess of 120 to 150 miles per hour. And so a drone weighs anywhere from 8 to 28 pounds, and that would destroy the drone, wouldn't it? So we're staying far away here, our friends from Nighthawk Productions, and that is a beautiful, beautiful piece of video. And they did a great job. And you know what? They were a long way away from that tornado. They didn't take any risks. Okay, let's continue. In fact, one of the things that I think, boys and girls, you need to know, and by the way, I want to say hi to Amy and Max and Eve. And Kim says her daughter Megan is watching. She's 18 years old. Well, here's what's going on. A lot of times when we have severe weather, it's because there's a change in wind direction. For instance, warm, moist air at the surface there. That's the area of red that you see. And then up above our heads, a cold front may be close. So that's shifting the winds in a different direction. It's colder air. Let's continue here. And as the tornadoes form, what happens is this change in wind direction is between the surface and the upper air. Now, you know what happens with warm air, right? It rises and cold air drops. So look at that. You have a dynamic tension in the atmosphere. The winds go horizontal, but because of the change in wind direction, look what happens as we have this rotation. It causes this horizontal rotation to actually go vertical because the warm air is rising, and it can rise pretty violently, really fast. And so it causes what we call a vortex. And the funnel cloud forms. Remember, we showed you the funnel cloud, and then it drops in the form of a tornado. And that's how, boys and girls, these things are formed. And we see this over and over again. Charlie, by the way, thanks for watching. You enjoy this. Owen and Will, glad you're watching this too. Okay, now let's continue. That's how tornadoes are formed. 3D radar. This is one of the things that we use. We've got our storm team is usually in the afternoon because that's when Angela Buckman and Sean Ash work, and they are the best in the business. And you'll see this in the often when they are covering severe weather, and I'm out in the truck following this stuff, or Miss Lindsay or Miss Kelly are. This is what happens. Notice how these clouds form. They rise. There's a lot of vertical. Vertical is up and down, horizontal flat. Vertical goes up and down. And you see the cloud tops on these severe thunderstorms. They could be 30 or 35 or 40 or 42 to 45,000 feet. And that's that warm, sharp updraft of warm air and then the cold air causing the violence. And so we'll have rain and hail and severe weather that will continue here. And, when Sean especially likes to use this, and I'm so glad that we have the capability here, we have things called shear markers. And this really helps us to identify the severity of particular storms. For instance, you'll notice here, look at the right-hand side of your screen. It says Covington and Petersburg. Those of you in Western Indiana watching, hello, Covington and Petersburg. That's where the Beef House restaurant is. And just west of that is not Danville, Indiana, but Danville, Illinois. Notice the green. Those are storms, but not really producing anything. But that storm on the south side of Danville, Illinois, we're watching the formation of really strong severe weather, potentially rotation, potentially hail, and a tornado. And we follow these shear markers, and they really help us. Let's continue now to see how these are mapped out for us. Here's how we bring you the weather. Now, I know that many of you, if you've lived in Indiana anytime at all when there's severe weather, you'll see us go on the air, and especially at night, those two folks that you see off to your left, Angela Buckman and Sean Ash, they do the majority of our storm coverage because that's when the majority of our storms occur, in the afternoon and evening. So there they are on TV, and this was at a storm a couple of years ago. While they were on TV, they were doing a great job showing the storms moving, the severe weather, the tornado warning. But what if you lost power? What if you didn't have TV? Well, that's where I came in on the right, and I was on for 3 hours talking about severe weather via Facebook and our WTHR.com weather page. And why do we do that? Because if you don't have power, you may not be able to see TV, but you can see your mobile app. And again, you'll see on TV a lot our commercials for the live Doppler 13 storm tracker. That's that big van with all the equipment off to the side. So we cover it, we track the storm and find out where damage was, where it may potentially be going. And then on your right, our WTHR weather app. Have you downloaded that? That's the best app we got going because that shows you what we call interactive radar. It's radar that you can use by moving your fingers. You can see where the strong storms are, where they're going, and where they're going to head, and where they've already been. Now, I want to pause just a few minutes because this is a subject that is near and dear to my heart. Now, I know many of you watching are in the city or in the metro area right now, but I also know that many of you are in the country. Now, my boys were in 4-H, all three boys, when they were growing up. And one of the things that they learned a lot about is water conservation. Do you know what that is? Well, it's saving water, and that's what we need to do a lot. And here's why. Less than 1% of the water on Earth is available for drinking. By the way, did you know that most of the Earth is covered by water, but only 1% of that water is available for drinking? And the average person, I know you're not going to believe this, but it's true, uses 80 to 100 gallons per day. You go, hey, how in the world can we use that much? Well, you flush a toilet, don't you? You brush your teeth. The average 8-minute shower uses around 20 gallons of water. Hey, by the way, here's my clue on saving water. Think of a song in your head, and as you're taking your shower, start singing that song and make sure that you're done with your shower by the time the song ends. The average song is between 3 and 3 minutes and 50 seconds. You'll save 10 gallons of water by doing that. And our drinking water comes from lakes and rivers and underground. Bottled water is so much more expensive than tap water. So make sure that you think about how you use water because we want to conserve that. And we thank Citizens Energy Group for giving us those tips and also for sponsoring our Weather Academy here today. Well, I know some of you may have some questions about this, and I want you to send me your questions via Facebook, and I'll answer them for you. A lot are saying hi, like Amanda says, hello. Carla says, I met you at the Indiana State Fair. That's cool, Carla. Hopefully we're going to have an Indiana State Fair, and I'll get to see you again this year. Let's see what other people are saying. Hello from Connorsville. We've had the app for years. Hello from Boone County. If you have a question, just send it to me, and we'll try and answer it for you. All right, let's continue with the Channel 13 Weather Academy, live from my house in a little room. We ready to continue? All right, let's talk about questions and answers. And, you know, one of my favorite teams anywhere is the Indiana Fever, our WNBA basketball team. You know why I got to like women's basketball? Because my mother played. My mother taught me how to set up pick, ladies and gentlemen. Let's go to our first Fever question and answer. Here it is, number one.
Now here's a real slam dunk. What does the weather have to do with potholes?
Oh, Natalie, not only are you a good player, you ask great questions. So here's the answer. What in the world does the weather have to do with potholes? You know what potholes are? That's the thing that your parents accidentally drive into, and it makes them really mad because it's a big hole. Well, as cars drive on the road, just the weight of the car causes wear over time, and we have cracks in the road surface. And as rain falls, that rain seeps into the cracks, and then the water actually just kind of sits there. Then during the winter, the water freezes and expands, and there's weakness in the roadway, and it's forced upward. So you know what happens, right? As the temperatures get above freezing, the ice melts, and ka-gung, ka-gung, ka-gung. There's the potholes. Boys and girls, potholes are something I've lived with all my life because I've always lived in the north. But 2 years ago, $2,300 damage done to my car because of a pothole. So we don't like potholes, do we, boys and girls? All right, Indiana fever, let's continue with question number 2.
When the fever hit the court, we hit like a fast-moving tornado. Do you know what they call a tornado that's over water?
Oh, does anybody know? If you know, send me your answer right now via Facebook. The answer is a water spout, W-A-T-E-R-S-P-O-U-T. Have you ever seen a water spout? I've seen one in my life. They look like tornadoes. They're over water. In fact, those of you who ever get to go to Florida, first of all, lucky you. And if you're ever in the Miami, Fort Lauderdale area, they don't often get water spouts, but they get them. And they look like a tornado on the water, and they're very threatening looking, but actually they don't cause much damage at all. The bark is worse than the bite. It's the same idea. Warm water rises, cold air may be aloft, causes that spitting vortex, and down you go with the water spout. All right, let's go to question number 3.
You know, our colors are fever red, blue, and gold. But have you ever wondered why clouds are white?
Oh, that's, Natalie, good question. Not only are they white, but sometimes they're green and gray. So that's probably the question I am asked the most when over the years I've gone to speak at schools. And just recently I sent the answer to a young man who had that question. Here was my answer. Okay, remember Natalie's question? Why are clouds white? Clouds are white because the sun is white. As light passes through the cloud, it interacts with the water droplets, which are much bigger than the atmospheric particles that are in the sky. So when sunlight reaches atmospheric particles in the sky, blue light is scattered more strongly than other colors, giving it the impression that the sky is blue. But in a cloud, the sunlight is scattered over more water droplets, and so it's white. Now, you may say, hey, once I was in a storm and I saw the clouds. We were out in the farm fields and they turned green. Is that true? Did they really turn green? Well, kind of, sort of, not really. What happened was that those clouds were low and actually were picking up the reflection of the corn and the beans. So that's why sometimes you have green clouds. Miss Mary, if you could bring our special guest over pretty soon. He's going to come over pretty soon. Let's continue, though, with our Weather Academy, okay? Now, what questions do you have? And I know that some of you may have some questions, so I'm going to check our feed here and see. Boy, we've got a lot of people saying hello from Lafayette, Crawfordsville, Boone County, and Crawfordsville. Hey, Joyce from Versailles this morning. Thank you for watching. Annette says, thank you for teaching us about, okay, Channing says, I'm 9. I love watching you every morning, and I want to be a meteorologist. Thank you, Channing. That's a very good job to have. And just work hard, studying math and science. Is our guest over here yet? Oh, he's coming. Okay, boys and girls, I want you to send me a question, send right now, and I'm going to say hello to our guest. Okay, buddy, come on over here. Some of you who get up really early and have watched sunrise while you've been at home from school may have seen this guy. He likes the weather a lot, except when it's stormy. He doesn't like it. Okay, come on over here, Lap. All right, buddy. Say hi to everybody. Say hi to the boys and girls. This is Senator. Senator's a really good guy. And sometimes now, since I've been working from home, he comes up and says hi to me on the air when I don't want him to. But I do want him to now. So, okay, off. He has a large head, but a wonderful heart. Okay, so let's see if there are any more questions. 8-year-old Sophia from Indianapolis says that she learned that not only you love the weather, but you also love basketball. She loves, thank you. Okay, Carla says, why has it been so windy lately? Well, you know, the jet stream, the river of air that separates warm and cold, we usually watch the two big flows of the jet stream, the polar flow, which, you know, isn't cool, and the Pacific flow, which is warmer traditionally. And so those rivers of air, many, many miles above our head, have been going at a very high rate of speed. And so today, like this morning, out at the airport, we had a 25-mile-per-hour gust, and we could see a 30-mile-per-hour gust about the time Miss Buckman is on at about 4 or 5 o'clock, about 5 o'clock this afternoon. But that's why the jet stream at River Bear. And sometimes in stormy weather, you can have really strong winds because remember that warm air is feeding up into the cold air aloft. So it does cause some violent weather. Let's say, hi, we are Aubrey and Braden. We are wondering what you do when there is a tornado when you are driving. Boy, is that a good question. So moms and dads, listen, what do you do? Well, when I first started in this business doing the weather, and it was, Miss Mary, how many years was that? 40? 40. 40 years ago, we used to tell people, get out of your car and jump in a ditch because you're going to be at the lowest possible level. And you know, there may be a strange, weird time when you do that because you're out in the middle of nowhere. So you find the lowest area and try to cover yourself. But usually if there's a sustained building, go into that building. Let's say that you're driving and there's a tornado and you see a Walmart nearby. Get out of your car, run into Walmart and go to the very back because there are no windows nearby. Or better yet, if you can get in someone's basement. That's what we like to tell people to do. But you want to, if possible, leave your car and get to a sturdy building, okay? Are tornadoes, this is from Amanda, more likely in the mountains or in the valleys from Jade? That's a very good question. You know, there aren't a lot of tornadoes in mountainous areas. There sometimes are, and most of that damage would be in valleys because there are wider paths of area that are flat. But honestly, a place like Colorado, now there have been tornadoes in Utah and Salt Lake City, but those are flat areas. So I guess that answers that. Blair, Harper, and Sydney want to know how fast the winds within a tornado are. That's a good question. So let's continue in the Weather Academy here with our little presentation because we're going to talk about winds and tornadoes and hurricanes. So when you guys have it up, just let me know. Oh, 2 more questions and pictures. So let's go to the question. Oh, okay. Well, tornadoes, you have a scale called the enhanced Fujita scale. I thought we were going to do that. That's okay. I can talk about that. The enhanced Fujita scale is a scale that measures tornadoes, and usually it's EF0, which is one of the more recent tornadoes that we had here, to an EF1, which is the kind of tornadoes that we see more commonly in Indiana, 1 and 2. And those can be winds in excess of 75 to 80 miles per hour and under about 115 miles per hour. And you imagine if you drove a car at 115 miles per hour, what kind of damage that could do if you hit something, right? We also have the scale for hurricanes, which goes up in excess of 180 miles per hour. But the reason, whenever you hear the Fujita scale, it used to be called the Fujita scale, and that was named after a professor, Dr. Fujita, at the University of Chicago. Most of the tornadoes in Indiana, not all, but most, are clocked between 75, 80 on up to about 115, 120 in that box. But can tornadoes be stronger than that? Absolutely. Let's do one more question. Okay. Go ahead. Let me see that. This is one from Andrew in the 4th grade. How many people die from tornadoes each year? I'm asked that a lot, and I do not know. Unfortunately, we had a tornado in Montgomery, Alabama area, and then on into western Georgia and Mississippi. It was really 3 states a couple of weeks ago that took 39 lives. We have had tornadoes that have taken more lives than that, more than 200 lives in Tuscaloosa, Tuscaloosa, Alabama, near the University of Alabama, and in Smithville, Mississippi. That was a tornado that went through Smithville, which was just south of where my dad and my brother lived, and then went into the University of Alabama area. As we go through time, because of watches and warnings, and I know, what's that young man's name again, Mary? Andrew, as we go through time and there's more announcements about watches and warnings, more people stay safe, and that's really important. However, sometimes we do have deaths, unfortunately, and that's what happened just recently in eastern Mississippi, in between Jackson and Hattiesburg, and then into Alabama. So that's sad, isn't it? Okay, what's next, guys? Tell me what's next. Okay, we are so thankful that some of you have sent in pictures. Angela Buckman, last time she was on Weather Academy, had people send in pictures, and she's put them on TV. And so here are some of those pictures, and we want you to send us a picture too. Just take a picture of it and send it to us via Facebook or Twitter. Isn't that a lovely picture? This is Ava from Westfield. You know, I love that picture because she's got, notice real carefully, she's got clouds and rain and a rainbow. And the Bible says God's never going to flood the earth by rain again, by flooding again. But notice the hope in the left-hand corner of your screen. Ava's got a sun. Good job, Ava. Let's see another picture here. Woo. Shannon, you've got it all too, buddy. All right, we've got rain and a rainbow and the sun. And I like the sun because the sun is smiling. Very, very nice. Very nice. And Kale from Westfield also has something, and that something is a tornado. And you got a severe thunderstorm, and that's really nice. That's a great picture. There you go. Oh, Amanda says, can cows really fly around in a tornado? It's happened, but I've never seen it in person, and I don't want to see it in person. I bet you saw that movie Tornado Twister, didn't you? Okay. I want everybody to enjoy the next few minutes because it's story time. And I wanted to do something unique because I love this book. I have a friend named Amy Sweezy, and for years, Amy has been a meteorologist at WESH TV, the NBC affiliate in Orlando. And Amy has done for years what I do in the morning, and that is the morning weather. And she's written this book that I love. It's called Let's Talk Weather, TV Weather Behind the Scenes. And I'm going to read that to you. We're going to talk a little bit too. We're not going to read the whole book, but most of the book. Not going to read the whole book because I have covered some of it. So here we go. Have you ever watched a weather forecast on television? Have you ever wondered how they can tell what the weather is going to be? Do they just throw a dart at a weather board? Do they just guess? And why are they sometimes wrong? All good questions, aren't they? Well, let's study that just a little bit, boys and girls. A typical weather forecast on TV might look like this. You see sunny, 80, 40% chance of showers, or what I would prefer to say is scattered showers in the afternoon. Notice there are three main things. 1, temperature, will it be hot or cold? 2, sky, will it be sunny or cloudy? And 3, precipitation. Will it rain or snow? Well, it's not going to snow in 80-degree weather, but it will rain. And that's the three things people want to know the most. Weather forecasts can be found in many different places. On the radio, for instance, if you ever listen to WFMS in the mornings, 95.5 with Jim, Deb, and Kevin, I'm on the radio too. A newspaper, on the internet, or even on a cell phone. Most people find out the weather they will be watching by watching a meteorologist on a TV network, or I would say a local TV station like WTHR. Why such a funny name? Well, meteorologist, it may sound like a meteorologist is someone who studies meteors, but when I was little, that's what I thought it was. But a meteorologist is a title given to someone who studies weather. Meteorology is the science of weather. Why such a funny name? Well, one of the earliest scientists, Aristotle, wrote a book called Meteorologica around 350 BC. That was a long time ago. Let me do the math on that. That was over 1,700 years ago. And he used the word meteorology to describe everything that happens above the earth, stars, clouds, meteors. Aristotle's term stuck, and that's the term that we use today, meteorologist. Weather is the word commonly used to describe what's happening in the air above the earth. The air above the earth is called the atmosphere. The atmosphere is a blanket of gases, including nitrogen and oxygen, that surrounds the earth. We need these gases in order to live. There are 5 layers of the atmosphere. Now, I know some of you are using this as a science class. So moms and dads, if you are running kind of a homeschool or e-learning thing, here's where I want you to take the quiz. Kids are all mad at me right now. All right, so here we go. The first layer is the troposphere. And that's where most of our weather occurs, boys and girls, in the troposphere. Then there's the stratosphere. Then there's the mesosphere. The mesosphere is where you see meteors light up. Did you know that? You catch fire right about there. Then there's the thermosphere, and that's the area of the atmosphere where satellites fly. That's as far as space is concerned, that's where the satellites fly at a pretty low level. And when the folks in the space shuttle go to repair them, that's the part of the atmosphere they're in. Well, there are many types of weather. A weather forecast is a prediction of what the weather will be in the future. Broadcast meteorologists spend their time on TV talking about weather. They usually talk about two kinds of weather, weather that's happening right now and weather that will happen in the future. I want to show you these three different kinds of weather. Do you know what types of weather this is? What about that first picture? Well, that would be snow. That would be in the winter, wouldn't it? And then the second picture, that girl is playing in a puddle, which is always a lot of fun. So that would probably be spring or summer. And then look at the boy out at the beach. Someday, boys and girls, we are going to get to go back out to the beach. I don't think it's going to be a long time. You hang in there. It's going to happen. Weather instruments. There are many weather instruments and tools that help meteorologists know the right now weather. Here are some of the instruments used by meteorologists to weather what is happening in the air above the earth. A wind vane. That's with the chicken or the rooster that you see there. It measures wind direction or whether the air is blowing from the north, south, east, or west. Then, how many of you have a rain gauge? Now, if you're in Boy Scouts and you've done the weather element, or if you're in 4-H and you're doing the weather, then you know what the rain gauge is. But it measures precipitation amount or how many inches it's either rain or snow. And did you know that officially temperatures, and you see the thermometer there, are taken 5 feet above the ground? There's the thermometer. It measures temperature or how hot or cold it is. And let me see. You see this, the cups that are spinning? That is Angela Buckman's favorite weather instrument, and that is called an anemometer. It's also the hardest weather instrument to say if you're speaking real fast. It measures wind speed or how fast the air is falling. Now, here's more on weather instruments. Knowing what the weather is doing close to the ground where we live, work, and play is important. However, a meteorologist also needs to know what the weather is doing way up in the atmosphere. That's when weather balloons are used. And these devices are attached, radio sondes, they're attached to the balloons and set up into the sky to measure the temperature and the air pressure and the wind and the moisture in the atmosphere. And then, of course, we have weather satellites. That's a tool that meteorologists use, and that's probably the one that we use the most, really, because they orbit the Earth and they send back images of the Earth from space. Let's go over here and see this page. Broadcast meteorologists use the cloud images to see if it'll be sunny or cloudy and to determine what kinds of clouds are moving into the area. Now, the shape, size, and height of the clouds help a meteorologist know what kind of weather is happening now and what may happen in the future. So here's a little thing I want you to do afterwards. Be a meteorologist. Go outside and look up in the sky. Do you see clouds? Can you tell what kind they are? Get on the web and then look. I'm going to go past a couple of pages because we've kind of already covered this, but we're going to talk. Remember, I talked about the Fujita scale. So here we go, and this will answer a couple of questions for you. First, let's talk about hurricanes. There's a big difference between tornado and hurricane categories. Now, when you think of tornadoes, you may think of hurricanes. They're both potentially harmful storms that rotate over land, over water and have high winds. Now, the main difference is that tornadoes form over land and hurricanes form over water. Hurricanes start at a Category 1, and the winds there can be 74 miles per hour. But look at this, Category 5 hurricanes, 157 miles per hour. I wanted to real quickly go to the tornado scale to answer the question that many of you had about the EF rating. That's the enhanced Fujita scale. A 0, 65 to 85, a 1, 86 to 110. And those are the most common tornadoes that we have in Indiana. 2, 3, 4, those tornadoes can be clocked in excess of 200 miles per hour in a rare E5 tornado. Some of you may have seen pictures of E5 tornadoes like in Moore, Oklahoma many years ago. Just really, really horrible tornadoes. And you have to stay safe. That's why we tell you about watches and warnings and know those very well. All the time, all over the world, instruments are collecting data about the weather. With this data, computers and people create maps showing the type of weather that's happening at any given place. A meteorologist can almost instantly access that information on the internet. Here you go. Before modern computers, it was impossible to know quickly what the temperature was in other parts of the world. But now meteorologists can find out how the weather is in France just seconds after the information is gathered. Just one weather forecast on TV relies on that information gathered by thousands of meteorologists, weather observers, weather instruments, and computers. They all work together to make the most accurate forecasts possible. Do you see that gentleman is doing the weather? He's in Japan. That's the island of Japan. And then this lady is in France. And these are from other parts of the world. Now, before I show you the last page, well, I did have it here. Okay, here it is. When I first started doing the weather, sometimes before some of your parents were born, we didn't have all of this equipment. And we had computers, and we had information that came from around the world, but it wasn't as quick and it wasn't as pretty. When I was very young, that's how I did the weather on TV. Who is that guy with all that hair? Doesn't really look like hair, does it? It more looks like kind of an animal pelt on my head. Anyway, notice that H. We had magnetic numbers that would go on the magnetic boards, and we would put cold fronts and warm fronts, temperatures and clouds and suns, and it's nothing compared to what we have now, which is just wonderful, I'm glad to say. All right, let's continue here. After collecting and studying the data, the broadcast meteorologist will share the forecast with viewers at home. From your TV, it looks as if the meteorologist is standing in front of a giant weather map, pointing to different areas and talking about the forecast. But really, she is pointing at nothing. When describing the forecast, most broadcast meteorologists are standing in front of a solid green wall. A filter removes all of the green and puts the TV graphics in their place, making it look like the person is standing in front of a map or other weather graphics. It's the same technology used to make your favorite heroes fly through the sky or dangle from a cliff in the movies. So how does a meteorologist know where to look and where to point on the map? There are television monitors on both sides showing the final blend of meteorologist and map, but it takes time to get the gestures and posturing just right, positioning just right. Now, that's my friend Amy, who wrote this book, and that's her doing the weather at West TV in Orlando. Now, looking at a mirror, do you want to do this? You want to practice at home? It's really easy. Here's how you do it. Looking at a mirror, find a couple of objects behind you, such as a chair or picture on the wall. Practice gesturing or pointing at those things while facing the mirror. Now imagine that all of those things are moving and changing, and that you're trying to inform the person in the mirror about them while smiling and without making a mistake. Now, if you practice, and I want you all to practice, you know what's going to happen? You might make a mistake because there's a lot going on, but you can do it. So how do you become a meteorologist? Well, many people, most people, go to college to earn a 4-year degree in meteorology or related science. To be a broadcast meteorologist, you'll need other skills too, including writing and public speaking. If you'd rather work behind the scenes, there are many options outside of television. You could study the weather for a government entity, like the military, for instance, or be a professor of meteorology or a consultant for a private company or work for the National Weather Service. When you see meteorologists on television, it's usually for only a few minutes at a time. But remember, they have already been at work for many hours looking over weather information to make the most accurate forecast possible. Broadcast meteorologists do not read the forecast from a script. They just talk about what they know. Now listen to this, boys and girls. Sometimes they may get tongue-tied. Sometimes they may use incorrect grammar. Sometimes they forget what they were going to say next. But since the forecast is usually broadcast live, the meteorologists must keep going. Above all, meteorologists know that the most important job is using their knowledge to let the viewer know what to expect from the ever-changing world of weather. Be the meteorologist. Meteorology focuses on math and science. This week, and here's what I'd love for you boys and girls to do, find a book from the library or online or in your home about math or science. Spend some time reading and thinking about the concepts. Maybe you could even do an experiment. Do math and science interest you? Do they make you wonder why or how? Do they make you want to find out more? If so, you may just become a meteorologist someday. And even if you don't want to be a meteorologist, all of those critical thinking skills will help you. Don't you love this book? Amy Sweezy, I think you're watching, Amy. Good morning, dear. And you've got a great book here. Amy can get you this book if you'd like to buy it at www.amy, A-M-Y, Sweezy, S-W-E-E-Z-Y.com. www.amysweezy.com. Before I go, can you hear me that? Thanks very much. We got time for one question. From Blair Harper in Sydney, how fast are the winds inside a tornado? Well, you know, like I was saying, as we showed you that Fujita scale, little small tornadoes, and there's not really such thing, but little small tornadoes with weak winds, 65 to 85 miles per hour. That's pretty fast. But sometimes you may hear Angela Buckman or Sean Ash or Lindsay Monroe or Kelly Green talk about wind shear or straight line winds. Boys and girls, those winds, and I live in eastern Hendricks County, can reach in excess of 100 miles per hour. In fact, several years ago, we had a straight line wind here in Avon that was 100 miles per hour. Okay, we want to say thanks to everybody who has been sending these in. Remember, we're going to post this, and next week we've got another Weather Academy for you, and I believe it's Kelly Green next week. Boys and girls, thank you so much. We're going to post this at WTHR on our Facebook page and on our Weather Academy page at WTHR.com. Hope you have a great day. Thank you, Indiana Fever Citizens Energy Group, and thank you, folks. Have a good day. Bye.